Air navigation. By TechIroki YouTube channel. Please subscribe for more tech updates. ATC is a combination of three elements. Set of flying rules. Multitude of electronic navigation system. Air traffic controller and the navigation. Navigation systems assist pilots in flying from one airport to another. These systems help both pilots and air traffic controllers determine an aircraft's position relative to the ground and to other aircraft. At high altitudes or during bad weather, navigation systems are essential for safe aircraft flight. Navigation systems have developed from primitive ground-based radio transmitters to sophisticated space-based systems. NDB, ADF, DVOR, DME, ILS, GPT, LT, markers ALS. Radar, NDB, non-directional beacons. Sometimes referred as location beacons. Used to mark airways, range may be 100 miles. Use a radio text to send out continuous steady note in all direction in MF band. A call sign of 3 letters in Morse code is used at regular interval to indicate the tuned beacon. You can see the pictorial view of NDB, non-directional beacon, and ADF, automatic direction finder. The automatic direction finder ADF or radio compass fitted in an aircraft will, when tuned to the appropriate frequency, indicate the relative position of the transmission source by means of a needle on a dial. The great disadvantage of the NDB is that it is very prone to interference. For example, a thunderstorm cell in the area will often cause the cockpit needle to point to it in preference to the beacon. DVOR, Doppler VHF Omni Range. It is the basic electronic navigation that in use today. DVOR navigation method relies on ground-based transmitters which emitted signals to DVOR receiver in the aircraft. The DVOR system operates in the VHF frequency band from 108.0 to 117.95 MHz. For optimum operation, the aircraft must be on the minimum altitude of 1000 feet above ground in order to pick up an Omni signal service range. Most VOR stations also have distance measuring equipment DME. A display indicator in the aircraft reads the signals and tells the pilots if they are on course and emitted in range to 160 miles and can only provide direct courses to or from AG. Ivan Station. This is the normal view of a VOR. DVOR ranges. DVOR class low altitude 1000 to 18,000 feet range 40 nautical miles. DVOR class equals high altitude 14,500 to 60,000 feet range 100 nautical miles. DVOR class equals high altitude 18,000 to 45,000 feet range 130 nautical miles. Rotating course card, it is calibrated from 0 to 360 degrees, which indicates the DVOR bearing chosen as the reference to fly by pilot. Omni bearing selector or OBS knob, used to manually rotate the course card to where the point to fly to. 2 from indicator. The triangle arrow will point up when flying to the DVOR station. The arrow will point down when flying away from the DVOR station. A red flag replaces this arrow when the DVOR is beyond reception. Course deviation indicator, CDI. This needle moves left or right indicating the direction to turn the aircraft to return to course. The horizontal dots at center represent the aircraft away from the course. Each dot represents 2 degrees deviate from desired course. The Airbus DVOR indication a bit different from above. DME, distance measuring equipment. DME, which is associated closely with VOR, the combination provides an accurate position fix. A special transmitter in the aircraft sends out pulses in all directions and these are received at the DME station on the ground. As each pulse is received, an answering pulse is automatically transmitted and this is picked up in the aircraft. It is in fact the reverse of secondary radar. As the speed of radio waves is constant at 186,000 miles per second, a computer in the aircraft which measures the time interval B, W, the TXNA pulse or the receipt of the response can convert this time interval into a distance or display it to the pilot in nautical mi. Less. DMES are normally co-located with VORS and the frequencies of the two installations are paired. For example, the VOR frequency of 112.7 MHz is always matched by a DME on channel 74, a VOR on 114.9 by a DME on channel 96 and so on. This means that aircraft equipment can be arranged so that the selection of a particular VOR frequency automatically means that the related DME channel is selected at the same time. ILS Instrument Landing System. ILS facilities are a highly accurate and dependable means of navigating to the runway in IFR conditions. When using the ILS, the pilot determines aircraft position primarily by reference to instruments. The ILS consists of Localizer transmitter, glide path transmitter, outer markers, approach lighting system. The ILS stations are installed in all the international airports, which support the landing aircrafts with instrument guidance under adverse weather conditions. ILS is used to provide the pilot precision information of the aircraft direction so as he lands the aircraft, if it is possible, to touch the ground in the specific point. This point should be the centerline of the runway and be at the beginning of the runway. In addition, aircraft is landed at an angle of 3 deg. So, the two of the landing guidance, i.e. runway centerline and 3 deg, angle landing path are provided by localizer and glide path respectively. The lateral and vertical guidance is necessary for a pilot to fly a precision approach where glide slope information is provided. A precision approach is an approved descent procedure using a navigation facility aligned with the runway where glide slope information is given. When all components of the ILS system are available, including the approved approach procedure, the pilot may execute a precision approach. ILS stations are classified in 3 categories: W, RT, the reliability. Category I, this permits the precision aircraft landing in ADH decision height up to 200 feet upwards of the ILS reference point. The ILS reference point stands about 150 meters from the aircraft touchdown point with the ground. Category 2, this permits the precision aircraft landing in ADH up to 50 feet upwards of the ILS reference point. Category 3, this permits the precision aircraft driving in an altitude up to surface of the landing runway. Localizer. Localizer, the primary component of the ILS is the localizer, which provides lateral guidance. The localizer is a VHF radio transmitter and horizontally polarized antenna array that radiates approximately 100 watts of RF power, between 108.10 MHz and 111.95 MHz. The transmitter and antennas are on the centerline at the opposite end of the runway from the approach threshold, as seen by the aircraft on approach to landing. The localizer station radiates a beam of information indicating the horizontal centerline of the runway. This beam is produced by 2 transmitters operating on the same channel frequency but amplitude modulated with different audio signals. The localizer station is identified by the transmission of a 4-letter identification code modulated at 1020 Hz and also by voice identification. Glide path. Glide path is a transmitter which gives information of the correct angle slope in regard with the horizontal level of the straight of aircraft slide during the landing. The typical glide slope transmitter is usually located 750 feet from the beginning of the runway and radiates a 5-watt RF signal from a horizontally polarized antenna array at an inclined glide path angle of 2.5 degree to 3 degree. The glide slope transmitter operates on one of 40 available channels provided by 150 kHz spacing in the UHF frequency range of 329.15 MHz to 335.00 MHz. Radar, radio detection and ranging. There are 2 types of radar systems installed each ATC ground station. The first, called the primary surveillance radar, operates on the principle of sending a narrow beam of energy, which is reflected from the aircraft under surveillance, and measuring its distance. Aims by noting the time lapse between the radar pulse transmission and its received echo. Thanks for watching. Please like, share, subscribe, or press the bell.